Section 7. Optimal extraction of exhaustible, non-renewable resources. By the end of this video, a student will be able to determine the optimal private timing of extraction and determine the optimal public or social present consumption. So far, we have learned that there are two kinds of resources, renewable and non-renewable. In the case of energy, we have some renewable resources such as solar energy, hydropower energy, biomass, geothermal energy, wind energy. And in terms of the non-renewable resources, we have fossil fuel, coal, nuclear, and natural gas. So, in terms of the non-renewable resources, what is the optimum level that we could consume them and extract them, and the efficient level of consumption? Assuming that we have a mine and we want to decide to extract and sell or not, is it cost effective for us to run this business at this point of time or not? To simplify this problem, we have to make some assumption. The first is that we assume that we have a mineral deposit of finite quantity. So we have a limited quantity which has a homogeneous quality. So if we dig in more inside, the quality of the mine doesn't change, which is very unrealistic, but we have to make it some more easier for us to solve this. The second assumption is homogeneous quality implies that marginal extraction cost is constant. So because the quality is across this mine is constant, so the more we dig in, we don't need to spend more money to extract. And deposit can be converted to raw material subject to a constraint in which the initial resource stock, we show that with S sub 0 and RT amount of extracted in each year. So our assumption is that total amount of raw material mined in each time period is equal to initial resource stock. So we have an initial resource stock. Every year we decide to extract some and leave the rest. And summation of all of those extraction is equal to the initial resource stock. So what is the optimal private timing of extraction? So we have to make a decision rule. So if we are dealing with the time, so we use the extract exhaustible non-renewable resource in time period when present value of royalties or rents per unit is highest. So whenever we have more, we can make more money, that's the time that we extract, very simply. So market price per unit in year T, we show that with P sub T, and it is the market price of the barrel of crude oil in year T, for example. Then we have extraction cost in year T, or cost of extracting a barrel of crude oil in year T. This is same could be used in the case of any mine. So we have a market price for copper or any other metal, and we have an extraction cost. So, and each year we have the market interest rate too. So we calculate the present value per unit by subtracting the cost from the price and divided by the market price to get the present value of each extraction in each time period. To elaborate that concept, let's consider this example. In case 1, when the market interest is 10%, we have 4 years or 4 time period. Price in each year is in the column of PT, and the cost in each year is constant, $10. So the net benefit or net profit of doing this business is $10 in year 0 present value, $10.50 in 1 year from now, $11 2 years from now, and 11.58 3 years from now. So when we do the present value, we can see that right now it has the highest present value. Should extract now since the present value per unit of royalty is highest, $10. So we shouldn't wait. Rent are growing at 5% rate. If rate of growth of rent is less than the market rate of interest, should extract now and invest proceed in financial markets. So we have another case, case 2. We have the interest rate 10%, but the same as the previous example, 4 time periods. The price of market is $20, 21.50 cents, and the rest, and you can see we have the constant cost in each year, and we can see that the present value of unit is $10 right now, 10.45 1 year from now, 10.93 2 years from now, and 11.43 3 years from now. So the maximum value is 2 years from now, so we have to wait for 2 years. Should extract in year 3 since the present value per unit of royalty is highest, and rents are growing at 50% rate. If rate of growth of rent is greater than the market rate of interest, should leave resource in the ground and extract sometimes later in the future. So in this case we have to wait to make more profit. So the third case is like this. We have these prices 20, 21, 22.10 and 23.31. The cost is constant as well. The present value is $10 in each year. So in this case we are indifferent between the extracting now or in 1 year or 2 years from now. So in this case we have indifference. Mine owner's indifference with respect to timing of extraction is ceteris paribus is everything, keeping everything constant. So mine owner at this time is indifferent. So you can rent it now or in the future, doesn't make any sense. So it's better to extract it now. Rents growing at 10%. If rate of growth of rents is equal to market rate of interest, resource owners in indifference between extracting now or in the future. So it's up to the owner. The next concept is determining of optimal public social present consumption. So cost to producer of extracting each unit of resource termed the marginal extraction cost. We show that with MEC. After some critical point, consumption of a mineral resource in the present time period imposes a cost on the future generation, or marginal user cost, which we show that with the MUC. So MUC is the marginal value of future satisfaction foregone by consumption in time period 1. Let's show that graphically. We can see that we have 3 lines over here. The horizontal line is marginal extraction cost. We have a marginal cost curve and marginal utility cost. We can see that up to point A, there is no up to point A, marginal utility cost is 0. Since after consuming the mineral in time period 1, there will be enough of a stock left over to meet all of the period's 2 demands. So any level before A is okay. But Total marginal cost of the first period consumption from the public stand out is given by summation of marginal extraction cost and marginal utility cost. So marginal extraction cost is cost of producers of extracting mineral in the present value. So we have to add the marginal extraction cost to marginal utility cost to get to the marginal cost. Marginal utility cost is the value of future benefit given up by the present consumption, opportunity cost of the present consumption. So whatever we consume today, there is an opportunity cost that we cannot consume it that in the next period. So whatever you spend in this year, next year you won't have that. So we have to see if it is beneficial to keep it your money to spend it 1 year from now. So that's the concept. So let's look at it graphically. At the present time, we are showing that on the horizontal axis. So in the time period 1, we can decide how much to extract and how much to save for the future consumption. Okay, at this time, when we are not considering the marginal utility cost of consuming in the next period, so at this point we just consider the marginal extraction cost and set it equal to the demand curve, and we reach to the point Q5. At this point, if we wanted to see what would be at this level of extraction would be the marginal utility cost in the future, we can connect this line to the equal to marginal utility cost. Given that the number is $8, so by doing this way, we are actually ignoring the marginal utility cost of consuming in the next period. But if we wanted to consider that, then our marginal cost would be summation of marginal extraction cost and marginal utility cost, and we reach to this marginal utility cost, the larger one. So if we set the level of extraction at this point equal to that point, we reach to the Q3, which is less than Q5. At this point, we see that the marginal benefit is 8 and is equal to marginal cost. In the next video, we will learn more about the renewable resources, more specifically fish and wildlife management.